In this video, we're going to look at the properties of parallel and perpendicular lines. So let's have a look at parallel lines first. One thing that you really need to know is that the gradient of parallel lines are identical. So, for example, there's a blue and red line there, and the gradient of the blue line is M2, the gradient of the red line is M1, and we're told that both of those lines are parallel to each other. That means that they're pointing in the same direction. That means their gradients must be identical. So M1 equals M2. What about perpendicular lines? So they're lines that intersect at 90 degrees. And they have a very interesting property that if you multiply the two gradients together, so M1 multiplied by M2, you get -1. Which is actually very useful. It's a very useful way of determining if two lines are in fact perpendicular to each other, or you have one of the lines and you wanted to find the gradient of a line that is perpendicular to that. So the formula would be M1 multiplied by M2 equals -1. And this can be rearranged. So you could, for example, find M2 if you're given M1 and you know that the lines are perpendicular to each other. Let's have a look at an example. So, question 1, okay. We're going to state whether each pair of gradients represent parallel lines, perpendicular lines, or neither. So, here are the two gradients. So, part A, M1 equals 1/3, M2 equals 3. The first thing we check, are they identical? And if they're not identical, well, they're not parallel. So the only other option that could be, potentially, is that they could be perpendicular. If it's not that, then it's obviously neither. So let's multiply the two together. So M1 multiplied by M2, okay, is equal to 1/3 times 3, which equals to 1. Therefore, not perpendicular. Okay, so that's the symbol for perpendicular. Also, M1 does not equal M2, therefore not parallel. So therefore it's neither. What about part B? M1 equals 0.6, M2 equals 3/5. So let's check M2 and compare it to M1. Well, 3/5 is the same as 0.6. Okay. Therefore, M1 equals M2. Therefore, M1 is parallel to M2. Part C. What about if we're given M1 is equal to 1 4/5 and M2 is equal to -5/9? So that's a positive gradient and a negative gradient. Well, clearly one's positive, one's negative. They're not parallel, so M1 clearly doesn't equal M2. M1 and M2 are different. Okay, hence M1 is not parallel. Okay. What about multiplying them together? So M1 multiplied by M2, okay, is equal to 1 4/5. Now, if we convert this into an improper fraction, you can see, you can actually see it quite clearly, in fact. 5 times 1 plus 4, it's going to be 9/5, multiplied by -5/9. Notice that one gradient is the negative reciprocal of the other, okay, and that's equal to -45/45, which is equal to -1. Therefore, M1, gradient M1 is perpendicular to gradient M2. And just a quick look at question 2. And just what I spoke about before, where if you want to rearrange the formula M1 times M2 equals -1 to find a perpendicular gradient, or a line with that's perpendicular to another line, find the gradient of a line that is perpendicular to a line with gradient 2/3. So what we want, okay, starting off with this formula, we want M1 multiplied by M2 equals -1. Now we have M1, let's set M1 to be 2 on 3. Multiplied by M2 is equal to -1. Okay, if we rearrange this formula, m2 is equal to negative 1 divided by 2 over 3, and that equals negative 3 over 2. So this gradient, negative 3 on 2, is perpendicular to a line with gradient 2 on 3. In fact, if you multiply these together, you can see clearly it's going to equal negative 1. So that would be this gradient here would represent a line that's perpendicular to the line with gradient 2 over 3.